Okay, we'll get started. Okay, welcome all. Today our webinar topic is troubleshooting common Modbus issues. We will focus on Modbus RTU in this presentation, but some of these techniques can also be applied for Modbus TCP, but realistically that's probably a different webinar topic, but let's get started. Okay, first of all, here's our agenda today. First, we will give a brief introduction into Modbus. Then we will explore some common issues with setting up a Modbus network and discuss troubleshooting tips and tricks. Finally, we will dig in a little further into some of these issues and how to identify and test Modbus communication errors. For a little bit about our company, ICP-DOS was started in 1993. Our headquarters is in Hsinchu, Taiwan, and ICP-DOS USA was launched in 2001 to support the North and South American markets. We offer fast service, free tech support, some free software utilities and tools, fast shipping, and a 1-year warranty. Our company is ISO 9001 certified. Most of our products are CE compliant, and we're also RoHS compliant. We're a Windows embedded partner, and our contact information is shown at the very bottom. There'll be further contact information at the very end. If you do have any questions, at the end we will have a Q&A session. You're also welcome to type in the Q&A box at the bottom of the Zoom bar to type any questions you may have that we can answer at the very end. Okay, a little history. Modbus RTU was originally created by Modicon in 1979 to be used with their PLCs. From its inception, it has been open source and royalty free, allowing others to utilize it to communicate to Modicon PLCs and other third-party devices. Manufacturers have also implemented this protocol as standard in their PLCs as well, many manufacturers. ICP-DOS has been providing Modbus solutions for over 25 years. Modbus RTU uses a master-slave architecture, sometimes called client-server, in which the server is equal to slave and client is equal to master. In this traditional format, there is a single master device that sends read and write requests to one or many slave devices. It is most often connected via RS-485, which allows a one-to-many architecture. The master device will always initiate the communication. The slave devices are assigned a unique slave address between 1 and 247. The read-write requests are sent from the master device in a specific format, which includes a slave address. The slave devices will sit idle on the bus until a read request or write request is received with its own unique slave address, and it will respond. Other slave devices will ignore those other requests or not directed towards it. Modbus RTU is most commonly communicated using RS-485, but is not restricted to RS-485. The benefit of using RS-485 is that it allows devices to be daisy-chained using only 2 wires, a twisted pair in this case, so that there can be more than one device on the more than one slave device on the bus. Let's see, the master device is traditionally a PLC, PC, or HMI. It is sometimes called a client in industrial terminology. The master device will always initially read-write requests for specific data from a specific slave device. The master device will then process the data to perform its desired function, whether it be to run a manufacturing application from a PLC, perform data logging, or control from an HMI. Slave devices, sometimes called servers, are each assigned a unique slave address. Slaves listen in on the COM port when a read or write command is received and is directed to its assigned slave address, it will process the request and either reply with the requested data or execute a write command and send back a confirmation to the master. Slaves will ignore requests not directed to its slave address. That is why it's important to set up a Modbus network with each slave with a unique slave address to avoid communication errors. Each Modbus slave has a Modbus register table like this. The Modbus register table is provided and shows a directory of available data and locations where the data is stored. The manufacturer of the device or the programmer of the slave device will define this table. The table will also include whether the available data is read-only, write-only, or read-write, meaning editable. For more information on Modbus registers or a deeper understanding of the protocol itself, please see our other videos. Today we will focus mainly on troubleshooting, but I just wanted to give you a brief introduction into some of the aspects of Modbus. Now let's get into some of the solutions, tips, and tricks for troubleshooting Modbus RTU networks. Modbus RTU is traditionally communicated over an RS-45 network. RS-45 allows for daisy chain wiring schemes to be implemented along a single bus. The maximum theoretical distance of the entire bus is 4,000 feet or 1.2 kilometers. Note that I said theoretical. Baud rate, wire type, and number of nodes can significantly reduce this distance due to wire resistance, signal loss, and communication distance. When the required distance is longer than 4,000 feet, or if the signal strength of the RS-45 signal is too low, you can add a repeater like our TM7510U. This device reads the incoming RS-45 signal and rebroadcasts it in both directions at full strength. One simple technique for determining if the signal strength is weak: measure the voltage across data plus and data minus terminals at each node. They should start off at 5 volts. As you move along the line, you will note the voltage drops as the signal gets weaker. When the voltage drops too low, the communication will fail, and at that point you want to add a repeater to read in and rebroadcast the strong RS-45 signal, and you can go another 4,000 feet theoretically. And you can keep doing this. You may need to adjust the timeout setting on the master device because it will add the slightest of delays, but most of the time it's unnoticeable. Adding a repeater will solve these types of issues. RS-45 is meant to keep all devices along a single bus. If you have a multi-story building, multiple assembly lines, which tend to be easier to branch off on, or if you are have devices in multiple directions, a wiring hub can solve this type of issue. This device has the 7514U, has one master port on the left side shown as D0, and 4 different slave ports rather, that are RS-45 in this case. So each slave device will still have to have its own unique slave address, but the signal will be broadcast along or from the master port to all 4 slave devices, or I'm sorry, slave ports, and only the device which responds, or which the command is directed to, will respond, and that transmission will be broadcast back to the master device through the D0 port. Here's an application example showing the i7514 in action. A second i7514U is also used in this example to further branch off or add devices in the network. Imagine if you had 6 identical assembly lines. With this wiring configuration, you could assign a dedicated RS-45 port to each line, And then this will allow you to easily isolate one line from another and add identical lines as needed if you want to add more ports. You would need to reassign slave addresses, of course, so that each slave had its own unique address, but this scheme and wiring scheme has been implemented many, many times. An RS-45 port is a COM port. The RS-45 baud rate and parity is set during installation. All slaves must have the same baud rate and parity option to communicate. Once in a while, there's a slave device which has a fixed baud rate and parity option, which will cause error issues. The TSH series, shown here, the TSH 725, for instance, has two COM ports, one incoming and one outgoing port. With each of these COM ports within the TSH, you can assign a unique baud rate and parity options, so that on the left side, in this case, it would communicate 9600 and 81, and on the right side, it would convert to 115, 200, even 7 and 1. If you wanted to change the baud rate back to 9600 after the device, you can install a second TSH module to the right of the device labeled device, and it would continue on at that new baud rate or the incoming baud rate. But the idea is all you're doing is switching the baud rate back on the other side. So each segment has its own unique baud rate. Let's see. A built-in buffer, helps to adjust for the baud rate and parity option or change. If you need, there we go. Yeah. Okay, next. DC biasing helps differentiate the ones and zeros in RS-45 communication. Standard practice is for the Modbus Master device to provide the DC bias, to pull the high state towards 5 volts and the zero state to 0. Some lower cost RS-45 converters and PC cards do not provide this bias because RS-45 chips do not have this capability. For these situations, we offer the TM-SG4, which would be an ideal solution. It provides bias resistors which help provide bias for the whole RS-45 bus. The module also has termination resistors which can be enabled to improve the RS-45 waveform. The bottom shows what the theoretical square wave for the RS-45 looks like, but in real life, the wave will be a little choppy and skewed. If the termination resistor value is too small or not used, it'll look like the middle waveform. If the resistor value is too large, it'll look like the waveform to the right. Normally, this is not too big of an issue for short runs and for what do you call it? Well, I guess short runs. We standardly don't even use DC or I'm sorry, termination resistor, but DC biasing is of course necessary. RS-232 and 485 ports are not traditionally available on PCs or laptops anymore. Using a converter like our USB to RS-45 converter, along with software, can both help in troubleshooting as well as configure and test Modbus devices. I cannot stress how useful having a USB to RS-45 converter like our TM7561 is when troubleshooting a Modbus network. If you have RS-232 devices, I would also suggest getting our i7561U, which has both an RS-45, or I guess an RS-45 or RS-45 capability, so that you can communicate from USB to either RS-232, 422, or 485 in this case. And we have Windows and Linux drivers for both of these models. They can be used to configure and troubleshoot Modbus equipment. They're also are great for simulation when testing, debugging, and developing a Modbus program. If you have a converter or the ability to use an RS-232 or a 485 port from your PC, Modbus simulators are very useful. Using the previously mentioned USB to RS-232/485 converters, along with a Modbus Master or Slave simulator, users can verify, write, and read commands, responses, uh, sometimes help with wiring issues, and data format issues as well. We provide a free Modbus Master Tool for Windows PCs. This is shown here. Our Modbus Master Tool is a free utility we provide for Windows PCs. If you have one of our TM7561, the i7561U, or any third-party RS-232 or 485 converter, you can connect your PC in place of the Modbus Master and test communication to your slave devices. You can read data in engineering, hex, or float format to help debug and simulate your application. Later, we will discuss scaling. Since Modbus devices traditionally give raw values, you can use this tool for assistance in scaling your analog values. It's very helpful in verifying if your software is reading the values right, or if your device is not putting out the right value. Almost all the time, it's going to be the scaling on the PC side or the number format. Slave simulators do the opposite. Let's see, we unfortunately don't have one, but there's a few out there. Specifically, just look at like modbus.org, and there's some just free ones and some that do a little bit more that you have to pay for, but they can be very useful. They also can be used with our TM7561 or i7561U to be a Modbus slave device or simulate a slave. With a slave simulator, you can simulate slave responses and monitor what values are written to the specific analog outputs. I remember an instance when a customer called in and said his analog output module wasn't working. He said it was always reading 0 within his software. What was happening was his software was only writing values between 4 and 20, when he should have been writing values of 4 to 20,000, which would represent 4 milliamps to 20 milliamps. We used a slave simulator in this instance, and we saw the values that were actually being written. They were so small that his software always showed it being 0 because it was so minuscule that it more looked like noise. When we finally investigated and used a slave simulator, we found that because the values were written as 4 and 20, and then we looked at the Modbus register table and found that we should have been writing, or he should have been writing rather, values between 4,000 and 20,000, and that was a quick, easy fix. Some of these issues here we have discussed prior. Let's see, just want to note some of these for additional troubleshooting. Let's see. For port type, make sure you're wiring to the correct terminals. RS-232 and 485 ports are not the same, so they oftentimes have different wiring descriptions and terminal descriptions. When using a USB converter, make sure you use the proper driver supplied by the manufacturer. When you plug some of those into the PC, Windows will sometimes pick the default driver, which is usually a prolific driver that may work partially but may not work completely. So I have seen that many a times. Let's see, for daisy chain wiring, be careful. It can be a little tricky to debug. We call our RS-485 terminals data plus and data minus. Others call it A and B, where B is actually the plus terminal and A is the negative. So it's opposite to what, I would think, but that's just how they have labeled it. I've also seen them call it RS-45 plus, RS-45 minus, but the main thing is you need to pay attention to the positive and negative polarity. Sometimes you need to connect a jumper as well. Some RS-45 ports are also partially used with RS-422 wiring. So sometimes you need to connect the RX plus and the TX plus to the data plus of the RS-45, and then the RX minus and TX minus to the data minus of the RS-45 terminal. Let's see, termination resistors are suggested for long distance wiring. For short runs, we usually don't use them, but in some instances, it may improve communication. So, please follow proper RS-45 wiring techniques. And, your electrician, and, by debugging, we can determine if they are truly required in your application. Signal strength is very important for RS-45, especially as you travel a long distance or go at a very fast baud rate. Biasing and proper wiring types are vital to good consistent communication. Marginal signal levels will lead to sometimes marginal communication, which will cause errors and sometimes bad readings, which of course will cause a timeout, which will cause many issues in your program. So it's always best to make sure your RS-45 signal strength is there. Repeaters and hubs we've discussed before. Baud rate conversion. Sometimes if you're communicating over a long distance and you want to do a high baud rate to some devices, you can use baud rate conversion along the line to make it so that the signal can make it to a certain distance, but then your slave devices may communicate at a slower baud rate, but the baud rate conversion module will help in that. We also have RS-232 or RS-45 to fiber converters, which can go even longer distances than 4,000 feet. And, at that point, I'd more or less probably recommend going to Modbus TCP, but we'll talk about that in a later situation. Let's see, next. When you have everything connected and you think you should have communication, you can look for these thingies. Let's see. Slave address. Okay. Make sure you have assigned a unique slave address and that you are sending the Modbus request to the correct address. Make sure the baud rate and parity are matching in both the master and slave device. Check the register table for the slave device. Make sure you're reading the right data. Some register tables begin with an offset of 1, so you may need to add 1, or if you're doing the opposite, you may need to subtract 1 from the register value shown in the table, but it depends on the configuration of the master and the slave device, how the tables are arranged and how the configuration of the master is set up. But trial and error can sometimes help. Try connecting the master to a master simulator and test that you're reading and writing the correct register. Also, sometimes there are gaps in registers, so you are not able to read consecutive registers. That's why if you're troubleshooting like one device, I would suggest if it's not responding, just try to read one register, a single register value with a known value. That will help you to verify you have the right register or the right sequence. Maybe you're reading one too early or one too late, but you'll have a good idea of that. Let's see, make sure your master device is providing the bias and the signal strength of the RS-45 is strong. You can measure this with a multimeter usually. Look for a slight voltage fluctuation when your master is communicating. If you don't see the fluctuation, you may have chosen the wrong COM port number that you're communicating to. Check for electrical noise. You can increase the timeout setting of your master device. Sometimes if your slave device is slow, far away, or you didn't allow a long enough timeout, then it'll cause errors as well in your program. Let's see, when you get a response, here are some suggestions, but if it's, of course, the wrong response, check the RS-45 signal strength. Make sure you don't have multiple master devices. Grounding. Usually you want to ground RS-45 on one side, but not both sides. That will cause problems. Termination resistors may be necessary for long runs. For short runs in which there's no noise or signal issues, termination resistors are usually not required, but please follow standard procedure. I suggest to test one slave at a device at a time. This will help isolate if you have uh, maybe two slave addresses the same, and start with the closest one and just keep adding and find out at what point it stops communicating. If there are, baud rate changes are necessary, or uh, repeaters need to be added, this is a great test to find out at what point and where the weak link is. What's different? Find out what's different about the non-responsive devices. Maybe it's at the end of the bus, or maybe it's near a source of heavy noise. You could use a simulator to test for that. Just connect your master to a slave simulator, either simulate one slave or multiple slaves, and just find out what's happening along the bus. Maybe your master device is pulling the wrong register, or some other issue like maybe wrong baud rate or something like that as well. Here is actually pretty much what I just said, but I highlighted some of the things that are most important when you get some response. So the most important ones are check the slave address and the Modbus register table are correct, because I've seen that many a times when customers are pulling the wrong register. Sometimes it's due to the manufacturer of the table not being very clear. Let's see, sometimes like we like to start off at registers like 40,001, 30,001 for our register tables, but sometimes they come up with these weird numbers that are in the middle of the whole range, and it just makes it hard to tell whether it's base 1 or base 0, and it is not very clear, so sometimes you have to test. That's why I always like to pick one register with a known value to try to test with first. You could always test the master using a slave simulator. That's one very good technique to make sure that you're pulling the right register, and if you need to, you can use a master simulator to test your slave devices to make sure they're responding each correctly. Towards the bottom, what is different about the responsive nodes versus non-responsive node? That's always a common question I ask, because it will oftentimes help. You want to check the data format. Sometimes like parity options can sometimes be skipped over. Maybe it's set for none 81 on the master side, but on the slave device is not set correctly. Also, sometimes it's just simply scaling. If you get a response, that's usually a good thing. If you get a wrong response, like say you're reading a level and your level is reading off at say 112%, that's not correct, but it could just be a matter of the number needs to be scaled. Slave devices traditionally do not do scaling, but it depends on the slave device. But in the end, it may be the master device that needs to be adjusted for the scaling factor. When you get the wrong response, like I said, it's oftentimes scaling. Sometimes it's data format, engineering format, hex format, and float format. Sometimes there's byte order that matters. You can use the Modbus Master Tool to read the data, or I'm sorry, read the data from the slave device, and you can read it in hex and figure out what value you should be seeing and what value you want to see, or what you should be reading, and figure out the scaling format. Oftentimes that should be documented in the slave device's documentation, but sometimes it's wrong, or you need to debug that. That's a great way to debug it. One register off, like I said. There's base 1 tables and base 0 tables, so just be careful of that. One rule or one thing I always look for is if the register starts off at like say 40,001, then you know it's base 1. If it starts off at 40,000 or it just has a 0x, then it's usually base 0. Make sure the right device is you're talking to. Sometimes customers may read the wrong slave device. You know, it's very easy to uh, configure your PLC wrong where you forget to or don't specify the correct slave device. It would be better if you can specify names within the Modbus table, but of course it's just a number and it can be very easily, you know, mislabeled or something as well. And finally, noise in the data line. That's usually a very bad sign. Usually we'd recommend wiring around heavy sources of noise if possible. And you know, just follow standard RS-45 wiring practices. Let's see, and we're ready for the Q&A session. I do see a few questions in the table. If you want to ask questions live, please feel free to raise your hand in the Zoom interface. Let me look at the questions now. Let's see, what voltage is too low so you need a repeater? Traditionally, it's 5 volts. Ideally, you want to look at a oscilloscope and see what the waveform is and why it's low. I tend to think like, well, I mean, on the conservative side, I'd say 4 volts. On the realistic side, I'd say maybe 3. But, you know, it really depends on how good of a RS-45 signal you're getting and how strong the waveform is. Meaning, if you can differentiate the zeros and the ones, that's really what matters in the RS-45. You said that you can use other RS-45 for other than RS-45. What is the other? RS-232 is also very common for Modbus communication. RS-232 is only one-to-one though, so it's good for like barcode scanners or devices which essentially have an RS-232 port. Most oftentimes it's shown by a DB9 connector, but you know it could be, you know, RS-45 as well. Just look at the documentation for the slave device. Specifically, you always want to look for Modbus RTU as the protocol. Sometimes devices may say they're RS-45 and people assume that it's Modbus RTU, but sometimes it's an ASCII-based protocol where it's just a terminal command needs to be sent and it's not Modbus RTU, so we get those type of issues all the time. But Modbus RTU can also be communicated over a fiber network. There's the Modbus TCP, which is the Ethernet version of Modbus, which is communicated over Ethernet. So make sure to differentiate between Modbus RTU and Modbus TCP. You know, there's RS-422, but Modbus doesn't define the communication port type. It just more so defines the structure and the function codes and the allowable address ranges. Most things are, you know, 0 to 255 or 0 to 65525, depending on hex data format. If I don't answer your question completely, please feel free to keep typing. Let's see now in the Q&A box. Do you offer any Modbus RTU to slave simulator software? We do not currently, but I know on the modbus.org website, there's one. I've used one called Mod RS, I think Mod RS Sim. That's very good. I know Cask makes one. It wasn't as easy as the Mod RS-232, but it was slightly more reliable. And there's one I believe also called Modbus Slave or Modbus or maybe Mod Slave. It looks nice, but I think it was paid, so you need to actually pay for that one. So, you know, those are just a few, but we don't offer any slave simulators. We do offer master simulators, but you can definitely use our USB to RS-45 or 232 converter to act as a slave and just use those to point to our COM port through our module. Let's see. Thank you, Joe, for your comment. Let's see. Any other questions? I'd be happy to answer any questions if you want to ask them live. Please just raise your hand in the Zoom interface. Let's see. Otherwise, let's see. Next slide shows our contact information. If you come up with questions after the fact, you can, email us or call us. I'm in the California office, but we also have our Houston, Texas office. We'll be happy to, answer any questions. We have many different Modbus solutions, so we got many field bus gateways. So if you do have, Ethernet IP or Profinet, Profibus type devices, and you want to change it over to Modbus, we have those type of gateways, and we have many communication devices. We have Modbus RTU and Modbus TCP slave devices, remote I/O, slave racks, those type, and we have programmable controllers, which can also be used in these applications. But I don't see any other questions. Again, thank you for attending. We'll see you next month for our next webinar. Okay, take care all. Have a nice one.